All right, so here we are on 11.2 on permutations. So what you're going to learn is how to use the fundamental counting principle to count permutations, how to evaluate factorial expressions, how to use the permutations formula, and find the number of permutations of duplicate items. So first off, a permutation is an ordered arrangement of items that occurs when no item is used more than once, and the order of arrangement makes a difference. Here, this is key, really, for the whole thing. Order of arrangement makes a difference. That tells you it's a permutation. Now, we use the fundamental counting principle to count the ways this can be done. So, an interesting fact, if you were to arrange 15 different books on a shelf and it took you 1 minute for each permutation, the entire task would take 2,487,965 years. Now, how do they figure that out? Well, if we have 15 different books, we can arrange it in one place. This is another book, and so there's all these different books. And first time you put a book down, there's 15 ways to choose different books. After you put that book down, there's only 14 left. And so the next place, you can choose 14 books to put in the next area. After you put that one down, there's 13, and then 12, and 11, and so on. And so when you get done, you get 1.307674368 times 10 to the 12th minutes. So quite a few minutes. Now we need to convert those minutes to years. So now we're doing some unit cancellation. And so if we convert so many units or minutes, that's going to be minutes per one thing. Now, if we convert that to hours, we divide by 60. If we convert that to days, we divide by 24. And if we convert that to years, we divide by 365. And when we do that, we get this value here. And if we round that up, that would give us our number with the 5 here. And so that's how in our book they got that number of years. Is they did this calculation first to figure out how many minutes there were going to be, and then they converted those minutes into years. So along those same lines, let's look at this next question here. So how many ways can the 6 jokes below about math be delivered if a joke in the form of a question is told first? So we have to have a question. All right, so how many of these are questions? Well, this one's a question. Why did that? Well, that's a question. All right. The amount of people, nope, that's not a question. That one's a question. That one's a question. And that one's a question. So it looks like 5 out of the 6 are questions. So if we have 6 books to choose, 1, 2, 3, 4, 5, 6, and we have 5 of them are questions, that means there's going to be 5 ways to choose that first book. Now, after that, we don't care what order is chosen. So after we've chosen out of those things, how many books are left? Well, if we've taken one of these away, there's still going to be how many books left? 5 books, because initially there were 6 total books, but only 5 with questions. So if we subtract one of those, we have 4 left here, but if we subtract one of those, we have 5 left here. So now there's 5 total books. Now, if they said the next one had to be a question too, then we'd put a 4 here. But they didn't say that. They said now it doesn't matter what order. So now we're going to have 5 times 4 times 3 times 2 times 1. Because after we've chosen that one, there's 1 less. And after we've chosen that one, there's 1 less. And after we've chosen that one, there's 1 less. And after we've chosen that one, there's 1 less. So now we have 5 times 5 times 4 times 3 times 2 times 1. And if we plug that into our calculator, what we get is we have 5 times 5 times 4 times 3 times 2 times 1, and we get 600 different ways to choose that first book being a question. And then after that, it doesn't matter. It's a specific order, but there's 600 ways we can choose this thing. So that is quite a few ways to deliver those 6 jokes. I guess we're doing jokes, not books, but we're delivering those jokes. So there's 600 ways we can deliver those jokes if that first one has to be a question. All right, so let's stop there and we'll come back for some more.